questions 438. Find all anagrams in a string. What it means is you want to find all the start index of an anagrams that is a substring in this long strings, and the anagram given is written in P. So our intuition will tell us that this question needs to be solved using sliding windows, right? With size of p dot length. So by using such a sliding windows, we will compare the values in these windows for every frames. So what's that value that we're going to compare? The values will be the number of counts of the characters within the windows compared to the number of counts of characters within the anagrams or the P given, the word P. And as long as all the characters have the same counts between the frames and the counts in the P, then we will append this index as one of our answer. And we want to append all the index of the anagrams, which means all the starting index of the sliding windows. So it's very obvious that such a comparisons will take about on to on square, which depends on how we're going to implement it. So let's start. So for sliding window, you can have a left pointers, right? And we also want to have a right pointers in a for loop. So let's go with right equal to 0, right smaller than s dot length, right blah blah. Before we begin, we want to ensure that there is a valid anagram exists. So base case, if the p dot length is have a larger than the s dot length, then we simply returns an empty array, because there is no impossible to have a anagram of p in s where p has a larger size. So every time we also want to store the status of the, which means the count of the sliding windows. And in this case, I will use an array to do that. So let's use an array. I will call it letter counts is equal to array dot 26. Why 26? Because I assume that, or the questions assume that there is only English letters in lowercase appears. So there will be 26 letters. Yeah. So we want to add the counts of the letters. Before we can do that, we have to get the index, right? So index means index of the letters. For example, A has an index of 0, B has an index of 1, and all the way to G, A, B, C, G. What's the last letter? I'm not sure. 25? Yeah, 25. Yeah, something like that. So first we want to have a letter equal to s dot right, and then we are going to get the letter index. So letter index is equal to letter dot character code add. So this is a method to get the, I think it's better to get the unique codes of characters of any characters, and we want to minus away the characters of A such that they are start yet, such that the index we get is a 0-based index. So this is something similar to what we have done in Java or in C++, such as A minus, or characters minus, I don't know, A minus A, yeah, something like that. similar. So we have a letter count, letter index plus minus 1, and we also want to shrink the windows if needed. Yeah, so when are we going to shrink it? I will say not now. If the window size is right minus left plus 1 is larger than p.length, then we are going to shrink it. So how are we going to shrink it? We want to get the leftmost letter, right? A typical way of implementing the sliding windows. So it's left, and we want to increment the left pointers a bit. We also want to get the index by using the similar codes. So leftmost index, and yeah, what's next? We want to, instead of incrementing the counts, we leftmost index, we decrement it. Yeah. So by doing this, we ensure that every time we reach this stage, the window size is absolutely smaller or equal to p.length. So what if the window size is exactly same as the window's length, or sorry, the length of p? Then there's a possibility that it is a anagram. So we want to check, is it anagrams? So how we going to check it? Since we already have a array.counts arrays, we can simply say check every single character count by using a for loop, but I prefer to use a better method. So I don't know, have you ever heard about hashing? So hashing a array, we are not going to do something very complicated. We simply want to compare the strings that formed by an array. So what is the strings? For example, if we have such a letter count array, we simply say constant hash strings is equal to letter count dot to strings, right? And every time we need to compare such strings with the string that we compute using the word p. So we want to compute the p strings also. So we say let p letter count, we get a constant, is equal to this, and for constant character of p, we get this letter index and we increment it. Yeah, and then constant p letter count strings, or we call it hash p strings is equal to p letter count dot to string, right? Later we can kind of print out the hash p string to let you guys to have a basic understanding of what it looks like. Actually we can do it right now. We can do it now. So let's run the code. Letter is not defined. Which letter is not defined? Letter. Sorry, my mistake. It should be here. Yeah. So this is what the hash strings of ABC looks like. So comparing such a strings is pretty straightforward. So let's do the comparison. So we say if hash strings is equal to hash p strings, then we have a result dot push what? Push the left index. So we'll also define a result as an empty array. Yeah, so are we done? Yes, we are done. This is all for our implementations. And let's use a more complicated test case. So what it does is actually we are hashing an array with a length of 26, and the comparison of this of an array with a length of 26 is pretty fast. It's the constant times, so it makes no difference for using this string comparisons compared to using a map or counters. I mean a set or a map counters to count the number of times that a letter appears. Sometimes in JavaScript this is even faster if you used to look at the internal implementations of how a two-string comparison is being done. So let's submit the code. Here we are. Not very fast, not very slow, but we can kind of persuade the people who interview you to say that you have a time complexity of O(n). Why? Because comparisons of two strings takes O(1), right? It might has a very large constant, but in terms of time complexity, we can still say that it's bounded by O(n). Space complexity, what's the space complexity it takes? Not really any space. At most O(1). Why? Because we only use an array with length of 26, right? So that's all for today's sessions. For the source code, you can refer to the link provided below, and for other LeetCode solutions that done in JavaScript, you can also refer to the GitHub repo below. Yeah, that's all for these sessions. Thank you.